All right, so we came up with three equations from Bohr's model of the atom. And so I'd like to do an example with you before I give you some homework questions. Okay, so it's going to be this example. And so part one says, for the hydrogen atom, determine the energy of the innermost level. Okay, so remember our equations are En is equal to negative 13.6 electron volts over n squared. That's one. A second one is EP, which of course is HF, is equal to E final minus E initial. And then the third one is the big radius one, Rn, is equal to Planck's constant squared over 4 pi squared k m q squared, all times n squared. Okay? So part one of this question wants you to determine the energy level of the innermost, the energy of the innermost energy level. Innermost is n equals 1. So En is equal to negative 13.6 electron volts over n squared, or negative 13.6 electron volts over 1 squared. So E of 1 is equal to negative 13.6 electron volts. Okay, that's part A. Part B says determine the energy of the second level. So that would be n equals 2. So again, En is equal to negative 13.6 electron volts. So E2, over n squared. So E2 is equal to negative 13.6 electron volts over 2 squared. So E2 is 13.6 divided by 4, which is going to be 3.4, negative 3.4 electron volts. This is the energy of the second level. So now it says determine the difference between the first and the second level as an electron jumps up. So EP is equal to E final minus E initial. If it jumps up, it means it's going from 1 to 2. So the final is 2 and the initial is 1. So EP will be equal to negative 3.4 electron volts minus a minus 13.6 electron volts. So EP will be equal to, that's a plus, so 10.2 electron volts. Right? So that's part C. Part D says, what is the frequency of the photon that's being absorbed? And it's being absorbed because, look, it's positive. So energy of the photon, what's the frequency? So we know energy of photon is equal to HF. So then F is just equal to EP over H. So it's equal to 10.2 electron volts divided by 6.626 times 10 to the negative 34 joule seconds. Oh, joule seconds, electron volts. We need to convert this to joules. So 1.602 times 10 to the negative 19 joules per electron volt. So 1.602 negative 19, and then divided by 6.626 to the negative 34, and you should get a frequency of 2.4661 times 10 to the 15th hertz. Okay? So you get a feel for how to do this. Then I could have said, what is the wavelength? Now, note that this equation is only for a hydrogen atom, but that I could find every energy level for hydrogen then, right? Like I could find the energy of n equals 1, n equals 2, n equals 3, n equals 4, etc., right? This one would be negative 13.6 because we just found it. This one would be negative 3.4 electron volts because we just found it. The next one would be 13.6 negative, of course, divided by 9. So to be negative 1.511. So I don't actually have to tell you the energy levels of hydrogen. I can just tell you their numbers. If we're doing it for any other atom, unfortunately, Bohr's model, Bohr's equation doesn't work for any other atom. And so I would have to tell you the energy levels or give you a chart to show you them. And your textbook does have a chart for a couple of them. Okay, so tonight's homework is going to be using these equations in class. The next day I see you, we'll talk about how come Bohr's model is supposed to be more stable than Rutherford's, even though it sounded an awful lot like Rutherford's. Okay, and then we'll talk about what the limitations are. And then we'll look at other atoms. Okay, so, but that's probably good for today. I'll let you to do some questions, and we'll see you tomorrow.